Okay, in this video, we're going to look at a couple of different ways that we can change the shape of the parabola and its location on the axes. Okay, so here we've got already graphed for us y is equal to x squared. Okay, and now in the last example I had f of x equals x squared. I used function notation to describe the machine, but here I'm just using y is equal to x squared. All right, so notice that since there's no coefficient in front of the x squared, we know in algebra that means that that coefficient is 1. Okay? So when that's the case, you know, we just have our regular parabola, just like we just graphed. That is, we have our vertex there, 1 over 1 up, 2 over 4 up, 3 over 9 up, 4 over 16 up, 5 over 25, and so on. That regular pattern of a parabola. So what we're looking at today is what happens if we change that 1 to something else like a 2 there. Okay? So in order to figure out what putting a 2, multiplying or changing the coefficient to a 2 does to the picture of the graph, we're going to fill out a table and check out some points. Okay? So here, just to kind of look at why this one is 18, remember what we're doing here is y is equal to 2 times the square of whatever number we input. Okay? So if we input -3, we're going to square it and get 9, and then double it, times it by 2. So 2 times 9 is 18. Okay? In this example, it's going to be, since it's a 2 there, 2 times whatever the input is squared. Well, the input is -2. So -2, we got to square that first, so that's 4. And then we times it by 2, so 2 times 4 is 8. Okay, so continuing on with that idea, go ahead and pause the video and fill out the rest of the chart. And we're back. Okay, so, all right, if you've done this, what you should have is, I'm just going to walk through it real quickly. If we input -1, if I input -1, square it, I get 1, and then times by 2, I get 2. 0 times, so I plug in 0, square it, still 0, times it by 2, still 0. Plug in a 1, square it, I get 1, times it by 2, I get 2. Plug in a 2, 2 squared is 4, times by the 2 in front, I get 8. And I can start to see if this is like the middle, -1, -2, -3 are forming a pattern of 2, 8, 18. And the other positive direction should also give me that same thing, because if I plug in +3, I get 2 times 3 squared. Okay, it's going to be the same as what we already did, because 3 squared is +9. Okay, so we get 18. All right, so how does it look when we plot those points? Well, -3, 18 is kind of off the chart a little bit there. Well, actually, this grid that I've drawn here goes up to 16, so if I just extend it a little bit further, I think 18 would be there. So -3, 18, right there. -2, 8, right there. -1, 2. Notice what I'm doing is I'm putting my dots. Let's go back to this one here. The dot on the original parabola used to be 4 above the x-axis. So the dot that I put just now was twice as high as the previous one, which would make sense because we multiplied it by 2 and to get our new y value. Similarly, the old parabola used to be 1 high. Well, now it's twice as high. Okay. So if we continue on with this, I'm just going to erase that yellow stuff there. I want that. Okay. So we're there. Okay. Technology. There we go. Okay. 0, 0. Well, something with a height of 0, if you double it, is still 0. Okay. 1, 2, twice as high as it used to be. 2, 8, twice as high as it used to be. And 318 is the last point. By the way, when I'm talking about 318, you know, again, an input of 3 and an output of 18 kind of means a point on the graph with an x value of 3 and a y value of 18. All right, so if we connect those dots, let's sort of figure out what happens. So what happens to the parabola? It does look like it got thinner, and in kind of a way we can say it got thinner. But a better way to think about it is it got stretched vertically. Okay? It got taller, if you will. In other words, the parabola, this point used to be 4 high, now it's 8 high. So all of the y coordinates for every point got twice as tall as they used to be. So we call this in math here a vertical stretch, and the scale factor is kind of like how much did the height change? Well, the scale factor is 2 because it got twice as tall. We'll notice that that's that number in front of our in our original thing that we were graphing. Okay, so sticking a number in front of the x squared vertically stretches it. So I'm going to go switch over here to look at a parabola. So this is that basic parabola with a 1, 1, 2, 4, and so on. So this one here hasn't been stretched. And over here on the left side, if you can see where my little mouse is going here, I have an a in front, and then a right now is set to 1, so it's like it's not doing anything. Okay, it's just like a regular parabola. But watch what happens when I multiply, or when I change that number in front to something bigger. I can see those points are going up. They're getting vertically stretched. So for example here, when a is 3, okay, my point used to be here at 1, 1. Now it's 3 times as tall. Okay? So it vertically stretches. You can sort of see that happen. Now, if we kind of go the other direction, okay, so there it's 1 again, so there it hasn't been stretched at all. How's it going to look if I now drag my slider to the left and make a number that's smaller than 1? Well, you could imagine if I start going into decimals and I make it a smaller than 1, the parabola gets vertically stretched by a scale factor of that value. So when a is 0.5, it kind of got squashed, right? So instead of going 1 over 1 up like it used to, it now goes 1 over half as much up. And so let's go to the green point. If you remember, a regular parabola used to go 2 over 4 up. Well, now it only goes 2 over 2 up. And then 3 over 9 up now only goes 4.5 up. And if I had the point on here, which I don't, you'd say 4 over used to go 16 up. Well, now it only goes 8 up. Okay? So when the number in front is greater than 1, it gets taller, stretched up. And when it's between 0 and 1, a little fraction there, it gets smaller and smaller and smaller. Okay, notice here when a is 0.2, 0.1, it's really getting squashed flat. When a is 0, it's squashed right down to the ground. Okay, and it's just like a straight line across. Okay, so just looking at the stretches there, it's kind of a fluid deal. So if we go back to the right thing, here we've got 1/2. So we could fill in the chart here, but let's look at how let's skip the chart and let's actually graph this thing. Okay, so right here is y is equal to just regular x squared, so 1x squared. So we're starting off with, just so we can look at it and compare to it, a regular parabola. So all I'm going to do to draw this thing is I'm going to take all my heights and I'm going to multiply them by 1/2. So this one here is a height above the x-axis of 16. I know that because I go 4 over 1, 2, 3, 4, 5, 6, 7, 8, 9, it's 16 up because it's like squared. So if I multiply my height of 16 by a half, I'm only going to go up to 1, 2, 3, 4, 5, 6, 7, 8. Okay, I'm only going to go up to there. Right next to it is this green point, which is 9 high, because it's 3 squared. So it's going to go to 4.5 high. So it's going to go to there. My blue point is 4 high, because it's 2 squared. Well, now half makes it go half that height to there. Now, whatever I do on one side, because of symmetry, okay, I do to the other side. So we get that deal. And that's there. Let's do the ones. So the 1 here is 1 high, so now it's going to be half high. I'm just going to erase that. So basically what we're doing is we're taking the shape of the parabola, that sort of skeleton of points there that we kind of work with, and we're just changing their heights each time based on that number in front of x squared. Now the vertex is sitting right on the x-axis, so it has 0 height, so it doesn't move. So putting all this together, our new parabola looks like this. All right. So, the short story of all that stuff is, if a is greater than 1, if that number in front is greater than 1, the parabola gets, say, taller. Okay, like vertically stretched taller. If we're a fraction between 0 and 1, or a decimal in front of the x squared, then the parabola gets kind of like vertically squashed. Okay? And we do it in the way that we were looking at there above. Okay? So far we've looked at changing that number in front of the x squared, but we've only looked at positive numbers. So, on the next page, what's going to happen if we make that number in front negative? Well, really what we've got here then is we've got y is equal to, when I write negative x squared, it's kind of like negative 1 x squared. So I'm making that coefficient in front negative. All right, so here, as always, we've started out with a y equals regular x squared, so just a normal parabola. Let's fill in a couple things in the chart to see mathematically what happens. Let's start here at the bottom. So when we plug in 3, y is equal to negative of whatever our input squared is. So we square the 3 that we plug in, and we get 9, and that negative 1 in front multiplies it and now makes it negative 9. Okay? Plugging in 2, well, it's going to be negative 1 times the 2 that we plugged in squared. So that's negative 1 times 4, so that's negative 4. So if we continue this on, plugging in 1 squared is 1, times the negative is negative 1. It's basically making all of our numbers negative. So plugging in 0 squared is 0, times negative doesn't do anything. Okay, let's do this one. So y is equal to negative 1 times, well, now we're plugging in negative 1. Well, negative 1 times negative 1 is going to become positive 1. Right, so that's now positive 1, so that works out to positive 1. And then negative 1 times 1, negative 1 again. And we know by symmetry that these numbers are going to repeat. Well, basically, what that means to our graph then is instead of going up, we're going to go down from the vertex. So if I look at our point here, 3, negative 9, well, that's 3, negative 9 is down there. 2, negative 4, right there. Why does it do that? 2, negative 4 is right there. Dang it. Is right. Why isn't my pen working? Let's do something like this. Okay. So 2, -4 is there. 1, -1. So we're growing this parabola upside down in the negative direction. Okay. -1, -1, -2, -4. There. Okay. So the moral of the story is, if the number's in front negative, it makes it grow down instead of up. So if we go flip back to our thing here, we only looked at positive numbers being stretched up. Watch what happens when I get to a negative number. Okay, so there my A number is still above 1. Now my A number is 1, so regular parabola. Now my A is a fraction. It's going to get squashed, squashed, squashed. It's going to get flatter and flatter, kind of. Okay, 0, flat. Now, as I go into the negative zone, it's kind of a flat parabola, but this time it's going down instead of up. If I go to -1, there's a completely upside down parabola. 1, -1, 2, -4, and so on. And then, if I continue on having bigger negative numbers, it's upside down and stretched. Okay? So upside down and stretched, negative coefficient, positive coefficient. Okay? Yay. All right, so when we take a look at this one, we don't really need to fill out the chart. We're trying to get away from having to do a T-chart all the time. Let's just see if we can figure it out. We know that this is going to go, it's going to be upside down, and it's going to be vertically stretched by a scale factor of like 2. So, watch what I do here, okay? So, the vertex is in the middle. Well, so upside down doesn't do anything to it because it doesn't grow at all. And vertically stretching doesn't do anything to it. So now let's do the 1 point, okay? 1 over 1 up. So instead of going 1 over 1 up, I'm going to go down, and I'm going to go twice as far. So I'm going to go 1 over twice as far down. Okay? And if I do it on one side, I do it to the other because of symmetry. So there's my new sort of first point over. My next point over, let's talk about these guys, used to be 2 over 4 up. Well, now I'm going to go 2 over. I don't change the amount that I go over. It's only ups and downs. So instead of going 4 up, I'm going to go down and twice as much. So I'm going to go 8 down. So that takes me to there. And if I do it on one side symmetrically, I do it to the other as well. So instead of going 4 up, I go 4 down. I'm going to lose it. Okay. Come on, pen. Why? Okay. Yes. Okay. So if we connect the dots, we should end up with a parabola that is growing in the negative direction, that is upside down, and stretched by a scale factor of 2, making all of its distances double what they should be, right? Instead of 4, it's 8. All right. So just something to write here, that when this this number here, when it's negative, we grow upside down. All right, so in that video, we really just covered vertical stretch. If it's positive, if that number in front, that coefficient A, is positive, it goes up stretchy, and if it's negative, it goes down, upside down. All right.